What's up guys, I am here to explain Leetcode question number 70, climbing stairs. So in this question, we have been given a staircase, it has n steps and we can take either one step or two steps at a time. So we need to find number of distinct ways we can reach up to the top, up to the nth step. So how to find this? We are given some examples for n equals to 2 and n equals to 3. So let's understand this using this whiteboard, right? If I am standing here, right, and this is our first step, this is our second step, right? So if I need to reach step number 2, I can reach there through two ways. Either I can go like this or I can go like this, right? So these are two ways, one and two. Okay, but this is our answer will be two. Okay, if I need to reach n equals to 3, I need to reach here. So in how many ways I can reach n equals to 3, right? Uh, First can be if I just use one steps, right? This can be one way. Or what I can do is I can just do a double jump here and I can just jump from here again. So this will be way number 2. Or I can just use single jump here and then from here I'll jump 2 steps up to my destination, which is here. So answer will be 3 steps, 3 ways. So answer will be 3. Okay. So this will be it. If I need to reach step number 1, however, right, I need to reach here. So I have only one option. I have only one way to reach it, which is this. So answer will be 1 for n equals to 1. Okay. But if I need to reach n equals to 4 or even n equals to 5 or 36 or 45, right, the answer, the value of the answer increases exponentially. So how to get the solution for this? Okay, so we can use dynamic programming for this. Okay, so how does dynamic programming work here? In the case of DP, what we do is we divide the problem into various sub problems and then we construct our solution using all those sub problems. We aggregate all the values from those sub problems and then reach to our solution. Okay, so how can we use DP here? Okay, that's the question. Let's try to understand through this diagram. Okay, let's say I need to reach here. Okay, here at this step. Okay, so how many ways I I have to reach here? It can be determined using how many ways I can reach here, or and how many ways I can reach here. Okay, so using these two values I can calculate for this, because if I am here I can reach here using only one way, and if I am here I can reach here using only one way, right? Because that will be two jump from here and one jump from here. Okay, so let's assume this is our nth step. Okay, so dp of n will be number of steps that we need to reach here, dp of n minus 2, because it's 2 steps back, plus number of steps we need to reach here, minus 1. Okay, so this will be our equation for the dynamic programming approach. Okay, now we need to use this approach and get our solution. Okay, so how to do that? So there are two ways in DP itself. We can use either loop or we can use recursion. In this tutorial, I'm going to use loop iteration. So let's use it. I'm going to declare a vector which stores all the values for all these steps. Okay, so it will be of size n. n plus 1 because I don't want to use 0 indexing here, so I am using n plus 1, and it will be initialized with 0. Also, before that, we need to solve this for edge cases, right? If n is less than or equal to 3, the answer will always be n, right? If you see here n equals to 2, the answer is 2. N equals to 3, the answer is 3, of course, right? As I've explained here. And for n equals to 1, the answer is only and only 1. So we'll just return n. Okay, so we are done with the edge cases. Now we can start with our actual solution. So I have declared a vector here. It has n plus 1 values, and we are going to use this as one indexed array. dp of 1 will be 1, and dp of 2 will be. So now let's start the iteration. I less than equal to n, because this is one indexing. So as I have written the function here, we will just do this here, right? dp of I equals to dp of I minus 1 plus dp of I minus 2. Here you go. This will calculate our solution. Okay, and then in the end we'll just return dp of c, dp of n. And so this is our solution, and I'm pretty sure this is bug free, but God knows if it's true or not. Let's check it right now. Yep, all my 8 custom test cases are accepted here, but I need to use long integer here. Why? Because for n equals to 45, the answer is going to be very huge, so I need to use long, which is a 64-bit integer. Let's see. Okay, so it will work for it. Let's try for 45, which is the maximum constant here. Let's test it. Yep, it works. And then let's submit this and hope for the best. Yep, it got accepted. Right, so this is the solution. Here in this solution, as you can see, the time complexity is linear because I am going from 3 to n, right? Number of lines that it is compiling is linear. It's proportionate to n, right? And similarly, the space is also linear, which is n plus 1, right? It is proportional to n. So the time complexity is O of n, and space complexity is also big O of n. But here we can optimize this code further. We can optimize the space complexity to constant space complexity. So let's see how, right? So if so, let's understand this through this diagram, right? Let's erase all this crap. I already explained this to you. Okay, so if I need to, let's just zoom out, and I need to copy this side. Okay, very good. So this is our staircase. Okay, so if I need to reach here, right? I need the dp values for this and for this, right? I don't need the values for this, right? I don't need the values for this, right? I just need this and this. Also, if I am at this level, I need the values for the other two, which are just be, just before this, right? So I just need two variables to store these values, and then I can just conveniently swap them, right? So we can reduce the time complexity in this way to constant time complexity. Let's see how. So these two variables will be a and b. Okay. Let's declare a as 1 and declare b as 2. Okay, and now dp has no significance, so our answer will be ans. Let's initialize it with 0, so answer will be a plus b. Okay, now we need to do the swapping, right? If I have gotten the answer using this, I need to shift these two up above, right? So a will be b and b will be answer. So let's do this. A equals to b equals to answer. Okay, let's return this answer then. Yep, all my test cases are accepted here. Let's submit this code. Here we have optimized space. Let's see. Yes, it got accepted, fortunately. So this is two. So these are two approaches to solve this question. This is a very easy classical dynamic programming question. And with this question, you can also understand how this algorithm works actually. And so I hope you like this tutorial. Thank you very much. Bye.